All right, got it. Okay. Thank you everybody for coming in on time. This week is the camp week, so many people are not attending today. So that's why we have the recording. For those who are not attending, you will be seeing this. Maybe the good news is today will be slightly easier to follow. I purposely choose the topic which are easier to explain, but very foundational. So please don't skip this recording. For those who come, hopefully you'll experience a sense of achievement because the marks that we're doing here, it's quite a lot. You'll see later why. This is all prelim questions. The marks are a lot, but they are rather easy to do and understand. Hopefully that's true for everybody. Okay? All right. So, I think we have a mic test already. Okay, people, today we are, sorry, never mind, never mind. I'll go very quickly to explain what's going on here. Okay, guys, very quickly, let me just revise what is happening. From your holiday tuition, you have basic knowledge and you'll get your basic skills. Basic skill doesn't mean easy, basically what you're supposed to have. Yeah, you have to have, for example, you have to have quadratic factorization. It's considered a basic skill, not because it's easy, but because you need it. Or long division in amath, you need long division because you need it. So basic doesn't mean it's easy. Basic means you gotta have it. Now, we're talking about basic knowledge, and therefore you have basic skills. We also talk about trends. We start to talk about trends. Today, we're going to talk about trends because then you can talk about strategy. As far as I can tell people, Ariel, Ariel, Anu, Eben, Nicholas, schools tend to talk about this a lot, and they tend to not talk about the trends. We are doing trends, and the reason is very simple because if you have these two, I can finally do a pressure test. We are not doing pressure test today. I don't think we can do it next week also, or maybe the last week. But pressure test is important to settle a few difficult problems. Well, first of all, the difficult questions lah. You need it. The unfamiliar question, difficult, unfamiliar is different, but you have trouble, difficult, unfamiliar, and when you have too little time to study. Most of you are busy, or most of you have many subjects, or most of you have feeling that we are being a bit behind in Sec 3, so you have too little time. Pressure test is intended to solve those problems. If not in exam, you cannot do things like. Then you would have an exam practice. Think about what your school do. Your school talks about basic knowledge, basic skill, gives you a lot of practice. Oh, Kirana, welcome. Let's do a mic test. Kirana, can you hear us?
Yeah.
Okay. We're just starting, Kirana. Right. So your school will do this and your school will do that. Okay. Your school will jump from here to here, and therefore there you go to exam. Your school don't do strategy. What do they tend to ask? Why do I ask that kind of thing? What is their responsibility when asking this? How do they think? That kind of thing. That kind of thing I find is very useful in amath and chemistry. We spend a lot of time doing that. Gonna spend time doing that today. If you do not have strategy, it's very difficult to pressure test you. The result of pressure test should be that you feel very confident. You have good timing, you have good skills, you have good knowledge. They don't do that. They don't do that in school. They jump from basic skill to exam practice and then to exam, right? So we do strategy because we need it for pressure test. It's very difficult to pressure test you without strategy. if you don't understand what I'm saying right now, I'm just telling you why I'm doing strategy with you guys, trend strategy, and you will reap the fruit starting Sec 4. So in Sec 4, the tuition will change a little bit. This is holiday tuition, is different. Starting school days tuition, I will do the pressure test. So I'll take a little bit of time, maybe 20, 30 minutes to pressure test you regularly. Okay, the reason is not to pressure you, but to give you confidence. Now, I hope you understand why we have to do holiday tuition. If we follow the school's tempo, we'll be doing basic skill. We don't even have time to do strategy. It's already exam practice and the exam. But if we have done this now, we can start to do pressure tests because we have done this and that. Then we can jump to exam practice when your school is also doing exam practice. Okay, that's why we do holiday tuition, so that we can start the pressure test early. I will not say early, I will say at the right time. If I start teaching you the basic stuff and the strategy during Sec 4, you will not have time for pressure tests. Then you will not reap the benefit. It may not make sense to you right now, but I'm just telling you why we're doing all this. You have no more question, I'll just get right to it. Any questions? Okay, so remember that we're currently doing trends to prepare you for pressure tests. Now, today I need a special setup from all of you, right? First, I've sent you the questions. This is the first question. I will now just erase all that. Okay. I need you to put this question in the good notes. There are two questions, this one and that one, okay? And then I need you to line it up just like that. I need you to line up side by side. There you go. Now, if you do not know how to do this, or if you have a technical problem, please tell me, right? One more time. I need you to line up two questions side by side. I'm going to do it that way. You're going to do it that way. Okay? It's just easier to identify the trend. Nicholas, you notice that I'm repeating stuff, yeah? So take it as a good repetition. Anu and Ariel, can you get the question in the good notes? It's from the WhatsApp group. I've tested already. It should work. If it doesn't work, please tell me right now.
Yeah, it works.
Okay, then put them side by side. If you do not know how to do it, it's very easy, please.
Do I put all the questions, like every single one?
Every question, but you notice that I actually send you 4 questions, just the first 2, but they are split. I have to, copy, I have to
Okay.
pop everything, but put one complete question on one page, put a complete question on another page, just like this. Okay. If you do not know how to split view, again, tell me. Eben and Kirana, can you do this?
Yeah, I'm doing it right now.
Cool. Eben, any problem? Technical.
I'm loading in the picture.
Good. Okay. Okay. Anu, are you done?
Yeah, I'm done.
Good. Now, I will start by claiming one thing. This is a differentiation question. You may understand it, you may not. It's totally new to you. That's fine. Just follow me for now. If this is Y, okay. Anu and everybody else, do we need some sort of rule? If you don't remember what I'm saying, please look at your notes. Remember, we have 3 rules, right? The times rule, the divide rule, and the inside rule. Do we need any rules here, Anu?
I think it's is it
Come on.
the times rule?
Times rule. And yes, Anu, everybody else, it should be very obvious that this is a times, correct? X squared times 6 minus x. So it's very reasonable to assume we need the times rule. They call it the product rule. Okay? There is no other reason. It should be very obvious to you that this is something times something. There is no other way to say. Right? So we call this the product rule. And for your refreshing is u prime v plus uv prime. Okay? Now, I'll give you and everybody else an option. I'll change it a little bit into that. Okay, I hope everybody can follow lah. Now, Eben, in the second form, I haven't done anything, I'm just expanding. Do we need any rule?
Um, mm,
Do we need any rule?
I don't think so.
And I agree with you, Eben. Why? There is no times, right? No times at all. There is no division. And there is no inside also. Correct or not? Furthermore, they look very basic. If you guys think that this is easy to differentiate, well, I hope so. It is very easy to differentiate. So now I'm going to split the group. Nicholas, you choose first. Okay. Which one do you want to do? The one
No
with
need.
the one no need. Okay. So Nicholas will do that. Okay. Eben will do that. Okay. Anu will do this one. I will give Kirana and Ariel choices. Okay. Ariel, which one do you choose? Ariel, quickly.
The second one.
Second one. And then Kirana, you choose which one?
Can I choose second one also?
Of course, no problem. We have one person here. So Anu and everybody else, do it in your own. I will also be doing it lah. This does not take long at all, right? So for whatever reason, you're trusting me, please find the dy dx. So please do so. Okay, Anu, you start first. Right? Okay, treat this as a warm-up, okay?
Can I take my calculator first?
Oh, please, quickly do. Quickly do. Okay, Ariel, can I have the result for the second one?
Wait, give me a minute. My GoodNotes crashed.
Okay. Nicholas, second one, please.
12x minus 3x squared.
Right. I did make a mistake. I'm sorry. This is supposed to be 3. Right. Okay. Anu, can you confirm the the first method also gives you the same thing?
Wait, sure. Can I have one more minute?
Sorry, I cannot hear you.
Can I have one more minute?
Can you what? Sorry?
Can I have one more minute to do it?
Oh, sure. Mhm.
Yeah, I got the same answer.
Good. Now, everybody else, I hope you do get this, and then you do get that. Look, using product rule or not using product rule, the result is supposed to be the same. I hope that makes some sense, right? It is supposed to be the same. Should you avoid product rule? Well, yes. Yes, please do. Please do. I'm just giving Anu a challenge. Sometimes you cannot avoid, ma. When you can, please do avoid it. It's usually just a better thing. Is everybody clear here? Okay, good. Ask your questions, yeah, if you want to. Now, I was asking you to believe me that we need we need a dy dx here lah. I was asking you to believe that. So let's make it a bit smaller and then just put it there. Okay, we have our dy dx right now. Okay, we do not know why. We're just doing a warm-up. Now, I am also asking you to do a dy dx here. Right? Please do. Please do a dy dx here. I want you to, everybody, find dy dx here, and then I'm going to ask a person. Okay, giving you 1 minute to do so. If anybody is bothered by the k, well, we'll see very soon how to deal with that. Okay, Eben, get ready. I'm going to ask you. All right, Eben, let's start. Eben and everybody else, please differentiate. What is it?
3x squared
Nice. This one?
plus 2kx
Very good. Then,
minus 3.
very good. And this simply becomes 0 for emphasis purpose, right? You don't have to write the plus 0, just for emphasis. Clear? Okay. Everybody, I hope you get it. If not, I mean, correct yourself, right? Now, do notice, people, the dy dx is extremely easy. Do notice that. Okay. This is that's why that's why I don't like it. Okay, never mind, never mind. Okay, never mind. I'll just leave it like that. Good notes problem. Good notes problem. Okay, people, do notice the differentiation is kind of easy for a prelim question and kind of common for this topic. Okay, it's kind of easy. Sometimes it is hard. Sometimes it is very manageable. Right? Now, I'm asking you to believe me. I'm trying to explain to you, okay, that this stationary point, whatever it is, requires dy dx. The nature, you will require the second one, never mind. The increasing one, you will also require dy dx. Gradient of tangent and blah, blah. I'm so sorry. Gradient of tangent, blah, 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 also require dy dx. Stationary point require dy dx. Decreasing function requires dy dx. I'm going to try to explain why right now. And then we can start to form a trend, right? Now, the most basic thing, Nicholas, please tell us, dy dx means something. Please tell us, what does it mean?
Y prime.
No. That's just a formal representation. That's not a meaning. Come on.
dy dx.
The use, Nicholas. The use.
Oh, gradient.
Thank you.
Gradient.
Why do we do dy dx? Thank you, Nicholas. For everybody else starting now, there is only one purpose. dy dx represent the gradient of the curve. This is all we need no matter what. Turns out that gradient is something very useful to be able to find. Turns out, you'll see later why. But the only sole purpose we learn dy dx is to find the gradient at a certain point. From now on, when you see gradient, it is the dy dx. The dy dx will give you a gradient. Please note, people, this one is not a number at all. This one is not a number. correct? Right now, I'm going to ask somebody, is somebody bothered by the fact that, this is supposed to be a gradient? It doesn't look like a number, correct or not? Who is bothered by that fact? I keep telling you dy dx is the gradient of the curve. Isn't that supposed to be a number? But this is not a number at all, and this is not a number. Who is bothered by it? If you're not very sure, we'll continue first, right? Now, I will show you something from Desmos first, right? Right. Now, with Nicholas, I've already shown you the graph. Now, Ariel, please confirm that this graph is what we have is question number 1. X squared minus 6, x squared bracket 6 minus x is the graph we have in the first question. Is this correct, Ariel?
Yeah.
Okay, good. Now, remember, I'm owning the green one only. The rest I'll just delete. Okay. I have the one from question number 2. I'm not turning it on yet. Now, look at the shape of the graph. It's quite normal. You get used to it. This is from email. The graph itself is not very scary lah, right? Now, there are 2 special points I'm introducing to everybody. This is a special point. We call this the minimum point, and we call this the maximum point. There's the maximum point, and there's the minimum point. Nicholas, you do have a question regarding the minimum and the maximum point. Please ask them.
If they're called the minimum point and the maximum point, why does it still continue going up and going down?
I hope you agree with Nicholas that that is a good question, yeah? Right? So I'm going to answer that right now. Okay. Okay, I'm going to put it here. Okay, so I have the graph here, and Nicholas is asking something like this. If this is a minimum point, how come the graph has something below it? Makes a lot of sense, yeah, Nicholas' question. If this is a maximum point, why the graph continues above it? Okay, the reason is because we just call this local minimum and local maximum. It is true, Nicholas, there is no absolute maximum or absolute minimum here. We are just talking about the local minimum and the local maximum because they have a very interesting usage. We lack a good words to describe them, so we just call them local minimum, abbreviated to minimum. Every time they call a minimum point, it's always just locally. Every time they call it a maximum point, it is always just locally. Nicholas, did I answer your question?
So it's just useful.
It is going to be useful beyond this question. I guarantee you in this question and beyond this question. No, I guarantee you. Yeah. Okay. Now, people, I suddenly talk about local minimum and local maximum, partly because look at the graph. That is the first thing that caught our attention. Don't tell me that the first thing that caught your attention is the thing that goes up or the thing that goes down. No one. Our eyes tends to gravitate towards the local minimum and the local maximum. I'll show you another proof. Curve number 2 is the second question curve. Eben, please confirm that is true.
The what?
The second curve, this one, the purple curve, that is the curve from the second question. Please confirm that first for everybody.
Yeah.
Okay, now I'm going to turn it on. Now, Eben, okay, this is kind of similar looking to the first one, just, a bit upside down. Eben, your eyes naturally fix it upon where? Your eyes naturally look at certain points of the graph. What is it?
The maximum and minimum points.
The local maximum and the local minimum.
Or
In fact, Desmos is also very interested in, isn't it? It's a very ugly answer, but Desmos immediately provided for us. He doesn't provide any other point voluntarily. He can if you want to, but Desmos immediately marked it for us. Like our instinct to pay attention to those points is also what this. Okay, the answer is very ugly, doesn't matter. The point is those are the local maximum and the local minimum. Now, to risk it, Kirana, the one on the left is this one. Let me just confirm, you help everybody else. That one is local maximum or local minimum, Kirana?
The left one,
Yeah, that one.
local maximum.
And how do you know? How do you know it's a local maximum? It is true lah. How do you know?
This higher than
It's
the
higher. It's a peak. It's a mountain, correct?
Yeah.
Kirana is correct, people. It's just obvious visually. Make sense or not? It's just obvious when we see it. Good job, Kirana. At the risk of being too obvious, Kirana, according to you, is this a local maximum or local minimum?
Local minimum.
And the reason why this is not a local maximum is because
It's lower.
it's lower, it's a valley, it's not a mountain, it's, I don't know. You can describe it anywhere you like, but Kirana knows that before we explain it, we don't need explanation. We instinctively know those are local minimums and local maximums. In this, I have to have a thumbs up first. It is natural when we look at it, correct or not, people? If you don't agree with that, please tell me. Okay, good. Now, I will show you what I have shown Nicholas, right? Nicholas, I keep claiming to you guys that dy dx talks about the gradient of the graph. So the gradient of the graph, again, the gradient of a graph is a very obvious thing visually. It is not something that requires too much explanation. For example, at this point, the gradient of the graph like that, right? At this point, the gradient of the graph, yeah, like that. At this point, the gradient is like that. The question is, in our special points, what is the gradient? Nicholas, you know the answer, so don't answer for us first. Okay. Now, Anu, venture a guess, please. In this local minimum, what do you think the gradient is? Or what does it look like?
Is it 0?
Is it 0, which means a horizontal line? Okay, the gradient 0 means a horizontal line. It depends on whether you can see it or not, people, but Anu see it that way. Now, Nicholas, tell us, what do you think about the gradient of the local maximum?
I think it's a horizontal line.
A horizontal line, which if you like, the gradient is also 0. Those two things are correct. Now, I want to make sure with all of you, Nicholas, sorry, I have to repeat this, just one last time, yeah? I want to make sure with all of you that you guys can see it that way, because no explanation is enough. It's a matter of seeing it. Okay, to Desmos. This is our point. Now, please understand something, people. I'm going to choose a random point for us first, right? Nicholas, please choose for us a random number.
7.
7. Okay, too much. Closer to -1, please. 1 or -1. Sorry, that will be too far.
2.
2, yeah. No, 2 are surprisingly too far also. Can I just go for half?
Okay.
Okay, half. So Nicholas has chosen for us a random point. Visually, you could see the gradient of this point. Visually, you can, okay? It's something like, I'm sorry, it's very difficult to show it. Now, I'm gonna show that the curve itself, if we zoom in enough, becomes a line also. Okay, I'm gonna show it. Okay, Eben, you're gonna help us with your eyes here. Does the graph still look like a curve? Let's try here first. Does the graph look like a curve? Is it still curvy, Evan?
Not so much. Like
Okay. If I zoom in, is it still curvy?
A bit, but very slight.
Slide. And if I keep zooming in, Eben, at this point, who can claim that this is a curve? Can you?
No.
Right. My point is, Eben and everybody else, with the power of Desmos, now we can zoom in. Every curve will become a line no matter what. And this line will be the tangent that you imagine. Does that make any sense, Eben?
Yeah.
Now, therefore, our task is, Ariel, here's the local minimum, right? Okay. Same question to you, Ariel. Ariel, does this still look like a curve?
Yeah.
Zooming in more, does it still look like a curve?
Yeah.
The question is, Ariel, can you imagine the gradient at that point, even though it is still curvy? Can you?
Yeah.
What is the gradient according to you?
This is 0, so.
0 or horizontal. So how do we confirm with the power of Desmos? We keep zooming in until, Ariel, is there any doubt at this point that the gradient on that point is horizontal or equal to 0?
No.
Yeah, good. Let's invite Kirana to observe one more thing. Kirana, here's the local maximum, right?
Yeah.
Kirana, can you visually imagine at the local maximum, the gradient is horizontal or 0? Can or not?
No.
Okay, what do we do, Kirana? Zoom in.
Zoom in.
Zoom in. Let's see. Because for a curve, if we zoom in enough, it will finally become a line one. There, still curvy. Can you imagine it now, Kirana?
Mm,
It cannot means cannot.
No.
You have to say. Okay, then what do we do, Kirana? We zoom in. Remember, Kirana, next time you do this kind of question, you can always apply Desmos and check for yourself. Do you understand?
Yeah.
I'm trying to demonstrate that Desmos is helpful. Now, here, still have a curve, Kirana and everybody else. Can you truly imagine that it is horizontal or still cannot? Kirana?
Can imagine.
Yeah. To confirm your imagination, if we zoom in enough, it truly does become a horizontal line. Can? It truly does.
Yeah.
Now, you have to imagine in an exam, but right now we're learning. So I am asking you to start imagining, hey, that guy horizontal, hey, that guy is horizontal, There is no other explanation. What else can I say? Either I use Desmos and zoom in, or I simply say, you gotta imagine it, man. I hope this makes some sense. Your teacher will say it that way also. She will not be able to explain it. There is no way to explain this. Okay, Evan, can you imagine the local maxima? Is it gradient horizontal or 0?
Horizontal.
All right. Now, Nicholas, do us an honor of the last one. Can you imagine it at this point?
Not really.
Okay,
But
so this one
zooming
even harder lah. This one even harder, correct or not? But so far, you're saying, so far?
Yeah. You zoom in, become like
Yeah. So far, logically, you cannot see it, but logically, it has always been like that. I am trying to teach you that, people. People, one more time, maybe you still cannot imagine it. But after a few experience, including this one, you will start to be convinced local maxima and local minima does have a horizontal gradient. If you don't believe me, please don't force yourself. You cannot. When your teacher start to do this kind of thing, use your Desmos to confirm. Desmos is your friend. Okay. I hope you will develop the imagination needed before exam. But as of right now, I'm using Desmos because I want to convince you, not I want to ask you to imagine without proof. Okay. All right, people. Okay. Go back to the question. Now, why are we spending a lot of time doing that? Because now I will start to decode some words to you. Stationary points simply means local maxima or local minima. Why? Because both of them have gradient equal to 0. Both of them. Please write this down. Okay, this is something new, but it's so easy to understand. Okay, now he never asked me to dy dx. I ask you to dy dx. I'm going to immediately use it. Okay, I'm going to immediately, because why? Because stationary points, which means local maxima or local minima, the gradient is 0. Remember, the gradient of a curve is the dy dx. This is something new today, but not difficult to understand. And therefore, it is 12x minus 3x squared. And I will now set it equal to 0. This is because this is the stationary point. At this point, all I am doing is combining this guy with this guy. I am just combining these two. Those who understand or can accept, thumbs up. Those who cannot, please ask. Let me see some thumbs up or not thumbs up. Okay. Anu, Ariel, and Nicholas, don't force yourself. If you don't get it, then say. But I need some confirmation whether you understand or not. Okay. Anu and Ariel, are you okay?
Yeah.
Okay. Anu, you sure?
Wait, when do you know when to differentiate?
Oh, okay. I'll answer that question straightforward, yeah. Okay. After a while, you will know that this is a differentiation question by experience. When are you supposed to differentiate? I will tell you this. Oh, this is a differentiation topic. Yeah, differentiation must begin. I just differentiate. Why? Look at the first part. The first part never say differentiation, but stationary points, the sole defining feature is that the gradient is 0. Correct or not? Remember, that's how you visually see it. Anu, everybody else. The local maxima and local minima has a defining feature, gradient equals to 0. Whether you can see it or not, I was training you on that. Correct, Anu?
Yeah.
If the defining feature is a gradient, immediately we think about using dy dx. Without the express command of the question will not tell you, yo, guys, it's a dy dx question. Don't forget to dy dx. They won't tell you. You have to remember it and rely on it visually also. I'm training you on that right now. Clear, people? Okay. Is that what you're asking, Anu?
Yeah.
Yeah. Now, most people will just not remember the theory I'm saying. Maybe just remember, oh, stationary point, dy dx. That's also fine. It won't be wrong one. It won't be wrong. That's okay. That's okay. Now, I am combining 12x minus 3x squared equals to 0. And I'm going to ask you guys, do you realize that you can immediately do something about it? Don't you realize that? The moment I equal to 0, I can do something about it. Ariel, do you realize that we can do something about it? Eben, do you realize that we can do something about it?
About the gradient.
Previously, we only have this, right?
Yeah.
Frankly speaking, we can only stop, correct or not? But now, with the stationary point, blah, 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 we suddenly have equal to 0, right? Suddenly lah.
Yeah.
Suddenly, we can do something about it. Well, that's the question. Does that make sense?
Oh, yeah.
Suddenly. You can do what?
Guess you can find x.
Yeah. Previously, you cannot.
Yeah.
Correct? Previously,
Okay.
You cannot. So please notice that, people. Now let's find x. So how are we going to do it? There are two ways to do it. You know what? No, I'm not going to explain that. Okay, I'm just going to do how the teacher will do it, right? Which is going to be very confusing, isn't it? He factorized the x out. Your teacher will tend to do that. Okay, your teacher will tend to do this, and then your teacher will say, therefore, x equals to 0, or 12 minus 3x equals to 0. X equals to how many? Okay, can I have somebody to confirm the answer?
4.
Okay, 4. Now let's go back to Desmos. 0 and 4. Please note, people, the math is very simple. Okay, you may be slightly confused, but the math is not complicated at all. Nothing we're doing right now seems complicated that way. Let's go back to Desmos. It is not a coincidence. Look at the maximum. Look at the local minima and the local maxima. Look at that. Do you see 0 and 4, people? It's not a coincidence, okay? It's not a coincidence at all that you found 0 and 4. Yeah, not a coincidence at all. Let's go back. Now, Anu, do the honor. Do we stop here? Do we get the 5 marks already?
No, we must find the y.
Very good. So we are very certain this is 0 comma something. And we are very certain this is 4 comma something. At this point, if somebody don't understand, don't thumbs up. Thumbs up if you understand. That is the last thing we're supposed to do. Good. Okay, great. Ariel and Nicholas, do you understand? All we have to do is to find the y lah.
Yes.
Yes.
Good. Now, Anu, do the honor. How are we supposed to find the y?
Sub x is equal to 0 and x is equal to 4 into the equation of the curve.
Which one? There I ask. Which one? At the risk of doing for obvious, do we sub it here or do we sub it here? Which one?
I think the top one.
The top one, not the bottom one. Why not the bottom one?
Because the
Mhm.
dy dx is equal to 0.
No. The dy dx is not always equal to 0. Remember, the gradient of the curve is not equal to 0 all the time. To answer that question, Anu and everybody else, now, to be fair, Anu is correct, okay? This is the curve. Therefore, this is not the curve. Do you understand, people? This is not the curve. This is the, but what is this? But it is the gradient of the curve, which is not the curve, whatever that means. It is something very useful that we need, but it is not the curve at all. Therefore, Anu is correct. If you want to find the point, go back to the curve. Go back to the curve. We have finished using the gradient just now. Okay, this needs to make sense because they repeat this all the time. It's a very basic thing that you're supposed to know. Yeah. Now, so therefore, let's put in the y. Let's put in the y. Okay, y equals to 0 times 6 minus 0, and no surprise, you get 0. This one is y equals to 4 squared, 6 minus 4. Go ahead, somebody, please tell me what is the answer.
32.
32. So people, this is hopefully not a surprise at all. That's 5 marks. Quite generous if you ask me. This is 5 marks. Now, if you are lacking in space because we split the thing, right? I'm so sorry. Because we split the thing, remember, all you have to do is just circle that and make it smaller, right? That's all we need to do. Oh man, the weakness of good notes. Anyway, go ahead and do that. Oh, yeah. I guess good notes has its own weakness. Need to select carefully. There we go. Okay, once you're done doing all that, please tell me. Please tell me. I need to see some thumbs up. Okay, I know it's there. Okay, good, Ariel. Okay, now I will show you why we compare two questions so that you can see similarities between them. Okay. Okay, I'm going to show my face. When I show my face, it's very serious. Okay, wow, so serious. Okay. Remember, guys, okay, in math and science questions, so many variation of question, only one or two type of answer. So many variation. Look at the first one. What? Stationary point. Use dy dx. Second question. Gradient of the tangent to the curve at point x equals to 1. What? So long. Also dy dx. So many variation. Just one or two tools. That's what you're learning. You're learning how to use a very powerful tool, a very useful tool to apply to many, many different types of situation. That's science and math for you. Yeah, humanity is a bit different. So I am going to immediately apply the same tool, dy dx, in a different question and a different curve. The gradient of the tangent to the curve at point x equals to 1. The gradient is the dy dx. Okay. What are we supposed to do? Let's look at the curve for a while. X equals to 1. Now we're going to type that equals to 1. Okay, there you go. There's the point. Now, note this answer, please, the gradient. Okay. Nicholas, the gradient of the curve, is it positive or negative here?
Positive.
Positive, yeah. So at least we got that from our Desmos lah. Other than that, we are not very sure. Let me confirm with you, Nicholas, for this guy, everybody else. The gradient is not 1 and it's not 2.5. Please confirm that that is the wrong number lah.
Yeah, that's not the gradient.
What is 1, 2.5? Just help everybody else understand.
That's
That's just the
the
coordinate
cross.
of the point, right? That's just the coordinate of the point. Why are we interested in this point? Please help us, Nicholas. Do you know why we're interested at this point?
Because he said, I don't know.
Because that's what the question asks there. That is what the question means. The question wants the gradient at that point. Nicholas and everybody else, do you understand?
Oh, you're looking at it.
Understand, yeah? That's because that's what the question wants. Now, please understand, people, the dy dx here is not equal to 0, obviously. This has to be clear, okay? I am using dy dx. I'm not equaling to 0. Not. Okay, Eben, please tell me, why not?
Because it's horizontal.
Equal to 0 means horizontal. So I shouldn't do that here. Why?
Oh.
Because look at the gradient at this point. Is it 0? Is it 0?
Oh, no.
It cannot be, right? Cannot be what? Cannot.
Yeah, cannot.
In fact, people, complete your understanding. The only point where the gradient is 0 is where? The maximum and the minimum. Do you understand? It's only there. So therefore, Eben and everybody else don't equal to 0 unless it's a maximum and minimum or stationary point. In this case, I don't know whether this is maximum or minimum. Please don't do that if you're not sure. Don't do this. Okay, don't equal to 0 if you do not know it's maximum or minimum. Clear, yeah? Clear. So what are we supposed to do? Well, this is a much easier question because he tells us the x. He did tell us that x equals to 1, correct or not? Nicholas, venture a guess. Venture a guess. Huh? What are we supposed to do with x equals to 1? He did tell us.
Uh, I don't know.
All right, I'm going to give you one more hint, okay? Look, the left question, they never tell you the x. They actually ask you to find the x. Correct, Nicholas?
Yeah,
But they tell you the gradient. The gradient is 0, y stationary point. Correct or not?
yeah,
This question is the reverse, right? They ask you to find the gradient, but they tell you the x. Correct? Is a reverse. Make sense?
okay.
Still have no idea what you're supposed to do with the x equals to 1? No guess at all? No
Is
guesses
it
at all?
supposed to be equal to what?
If you equal it to 1, it means you're saying the gradient is 1. But is
Wait.
that true? That's
No, no, no,
that's
no,
not
no,
true.
no, no.
That's not true. What do
You have
you
to
do
make
with
the x 1.
Yes, as easy as that, people. I hope that makes some sense. The dy dx contain x's for you to set lah, right? So now 3, 1, right? Plus 2k, 1 minus 3 equals to, please somebody tell me.
Okay.
And the answer is 2, 2, 2, 2, 2. Oh, yeah, it's 2k, isn't it? Oh, wow, it is 2k. Okay, now at this point, whoever is bothered by the K, please thumbs up. Whoever is bothered by the K. Ariel is bothered, I can understand that. Who else is bothered by K? Hey, Nicholas, you're no longer bothered by K. Okay, who else is bothered by K? Come on, let's be honest. Eben, Kirai, Anu, you're not bothered by K?
Doesn't look nice, but it's okay.
Okay, I understand. Kirana?
I don't know if I should be bothered because the first question it just asked in terms of K. But I don't know.
So in terms of K means you are actually happy with the answer or not?
I'm not sure.
Okay, Kirana has pointed out something very important. The question assures us your answer is supposed to contain K, even though you don't like it. Let's be fair, nobody likes it. Nobody likes the answer to be equal to something, not a number. But the question at least helps, how do I say, assuage our doubt, comfort us. We are at not a wrong position. That is the most comfort I can give you right now. You are not at the wrong track. You are at the right track. The answer is supposed to contain K. Okay. Other than that, the math is actually very simple. Mostly is the understanding that we're emphasizing. Okay. Now, if your discomfort is there, acknowledge it and we'll handle it in pressure tests. Unfortunately, putting K is a trend in amath. They will do this one without your permission. All I can promise you that it is very easy to handle once you are at a certain level. Okay, now I will go back to oh, this is the harder part. Cannot. We need to take a break. It's very hard. If I explain, I cannot stop. Okay, so Nicholas, feel free to follow using the recording. Everybody else, take a 5-minute break. After this, the explanation is slightly longer. Okay?
Bye.
Okay, bye, Nicholas.
My teacher said it's small, but I'll come tomorrow.
Okay, Ariel, if I'm not mistaken, you have to leave first, is it?
Yeah.
Okay, listen to the recording and don't be.
Okay.
All right, I'll see you then. Bye.
Thank you.
Anu, Eben, and Kirana, Anu, mic test.
Yep, I'm here.
Okay, Eben, mic test. Kirana, mic
Yeah.
test. Okay,
Yeah.
good. Kirana?
Yes.
Okay. Now, remember in science, many variations, just one or two powerful tools. That is how you must see it and learn it. That's the whole point of science and math. They're teaching you certain powerful tools. If you understand the tool completely, you can apply it to many situations. It has always been like that one. It's not one question have many answers. It's many questions have one answer. Yeah. Now, the answer that I'm promoting right now, so to speak, is dy dx, right? Now, increasing and decreasing turns out to also need dy dx. I'm focusing on the increasing and decreasing function first. Now, let me explain what it means. Again, visually, everything is pretty much visual at this point. I'm going to just a minute, sorry. Hmm. Yeah, I'm wrong. Sorry, I just have to adjust this. Right. Okay, much better. Okay, thank you. Sorry. Okay, now I can easily screenshot. I know that you cannot screenshot this, and usually I don't even need to do that. Just draw manually lah. It's fine one, right? Okay. If you feel that it's nice to have a visualization, then just draw for yourself. Right? There you go. Now, I claim people, everything is visual at this point. Okay. The gradient is visual. The stationary point, horizontal gradient, very visual. I am now claiming increasing graph for some reason is also something visual and something connected to gradient. Kirana, look at the second graph. I won't explain much what is increasing or decreasing. I will just ask you, hey, Kirana, this point of the curve, without much understanding or explanation, do you think that part of the graph is increasing or decreasing or do not?
Increasing.
And I hope people, it makes a lot of sense visually. You're right, Kirana. I agree with you. What else is the explanation? Now, the next part, Kirana. What do you call this part? Increasing or decreasing?
Decreasing.
And I hope that's very obvious. And last one, this one.
Increase.
Now, Kirana, do the honor, notice a few details. Now, I tell you it's obvious, but as a math student, we focus on some details lah. Do you notice the transition between increasing and decreasing, Kirana? Isn't that the transition? At the left of this point, it's still increasing. At the right of that point, it is decreasing. Correct or not? Does that make sense visually?
Yeah.
Now, what is this point, Kirana?
The X.
Yeah, don't call it the X. I mean, I mark it as X. What is this point? This point has a very interesting feature. What is that point? The point that draws you to that draws your eyes. Come on, Kirana. The point that draws your eyes.
Maximum.
The local maximum. Now, here, I put it in decimals. This is the local maxima. It's very ugly. Who cares? At the left of the local maxima, the graph is increasing. At the right of the local maxima, the graph is decreasing. Plain and simple. Correct or not, Kirana?
Yeah.
Everybody else, I hope that makes a lot of sense visually. Kirana, please confirm with the local minima. At the left, decreasing. At the right, increasing. Make sense? Kirana? If it doesn't make sense, you tell us. You're the representation right now. Make sense or not?
What do you mean the maximum is
Minima, local minima.
or minimum?
That point, local minima. At the left, the graph is decreasing. At the right, the graph is increasing. Make sense?
Yeah.
Okay, good. Now, one last thing to note, Kirana. One last detail to note. When the graph is increasing, the gradient of the graph. Is it positive or negative?
Can you repeat your question?
At the increasing part of the graph. Okay, at the increasing part. I'm going to delete that part. The gradient of the graph, is it positive or negative? If you don't understand what I'm saying, please tell me.
Positive.
Positive. This guy, positive, correct?
Yeah.
This guy, positive also. This guy, positive also. Before the maximum point, what is it? The gradient before the maximum point. What is it, Kirana? Positive or negative?
Negative.
Here's a maximum point, something like that, correct? Let's focus on that. Here's the maximum point, correct? That's your local maximum. Are you sure? The guy before the maximum point, are you sure the gradient is negative? Are you sure or not? You gotta see it lah. It's difficult if you cannot see it. Are you sure you are seeing a negative gradient before the local maximum?
No.
It's before it's positive, correct?
Yeah.
After is negative, correct or not? After is negative. Okay, so positive, 0, negative. The gradient. Kirana and everybody else, does this make any sense? I need some thumbs up here. Oops. Nice. Okay, good. Remember this. This is basic knowledge. The strategy and the trend is that they ask this a lot in a very plain way, and you will understand it using gradient. Will they draw the gradient for you, Eben?
No.
Good. Your job is to see it yourself or to draw it yourself, to ascertain it yourself. Understand?
Okay.
Yeah. Now, Eben, now you do us a favor on the decreasing part lah. So now this is the decreasing part, right? I hope everybody can simply say, yeah lah, that's the decreasing part, obviously. Let's analyze the gradient. There, that's the gradient, right? So tell us, Eben, is the gradient positive, 0, negative? What is it?
Negative.
Negative.
Yeah.
Here, negative. Here, negative, right? Negative. Decreasing is always negative. Let's confirm with everybody else. The negative is not constant, you know. It's sometimes more negative, it's sometimes less negative, correct? The gradient does change lah, correct or not? I mean, it's a curve, ma. A curve, the gradient will change one, correct or not? The gradient will change, but it's always negative, correct? Eben, unmute. Correct or not?
Yep, correct. Sorry.
Now, do us a favor and analyze the last part, the increasing part again. Look at the increasing part, they won't draw the gradient for you. This one is the increasing part. In this increasing part, what is the gradient?
Positive.
Always positive. At this point, I can use the word always already. Can?
All right.
Yeah. Now, Anu, do us a favor and analyze the first curve lah. Okay, the first curve. Okay. Increasing and the nature of the gradient, or decreasing and the nature of gradient. This part, increasing or decreasing?
Increasing. Oh,
De-
that part, sorry, decreasing.
Decreasing, and the nature of gradient is always?
Always negative.
Everybody else, Anu, you must be able to see this. If not, it doesn't make sense. The middle part, Anu?
Like 0.
No, the 0 part is here lah. There's a 0. Fine. After that?
Oh, that part. Positive.
Increasing, and therefore the gradient is always
Positive.
positive. Last one?
Decreasing.
Decreasing, the gradient is always?
Negative.
I hope this makes a lot of sense, people. This will always be correct, and this is how we answer why increasing and why decreasing.
But
Do you understand? Yes, Aizanu, go ahead.
Like for this kind of question, we won't see the graph, right? So how are we supposed to know the range like without seeing the graph?
A very good question, Anu. A very, very good question. I will tell you. Anu has brought up a very important question, especially for people in recording. Hey, I don't have Desmos word. How am I supposed to know? Fair. Easy peasy. Easy peasy. I'm supposed to teach you, right? But three. Look, based on our understanding, the m equals to 0 is very useful. Okay, one more time. The m equals to 0 is very useful. So I'm going to write this down. At x equals to, I have 5 x's. First is 0, and second is 4, because those are the stationary point. Please note, I already found it from part 1. The question is structured that way, I'd like to be helpful. The gradient, which is the dy dx, right? Anu, help us here. The gradient at x equals to 0 is, the gradient is?
0.
0, because that's what we found, huh? That's the stationary point. At x equals to 4?
8.
Okay, at x equals to 4, it's here. At x equals 4, it's there. This guy is 4,32, right? At x equals to 4,
Oh, it's
4,32, the gradient is also
0.
0. Now, Anu's question is, without the graph, how are we supposed to know whether this guy, positive or negative, this guy, positive or negative, this guy, positive or negative? In short, we're using the stationary point as our divider, our book divider. If there's an increasing or decreasing question, the first thing you think about is the stationary point. The first thing you think about is the stationary point. Hey, I got it already, great. Why? Because that is the divider. How come? When you're decreasing, if you want to transition to increasing, you must go through a stationary point. That's why it's a great divider. When you're increasing and you want to go to decreasing, you always go through a local maxima. It's a very great divider. I hope you understand this. So I am going back to stationary point, and now I ask, what is the guy before 0? That is the guy between 0 and 4. And what is the guy after 4? The answer is very simple. It's very simple. I just have to randomly test. I just have to randomly test. Evan, do us a favor here. Okay. We're going to test just anyhow between 0 and 4, this test. Okay, you are going to choose just a random point between 0 and 4 to test the gradient. Choose for us, please.
Like the number.
Like, I guess the x lah. That's
yeah,
what we, I guess, choose lah, right? So choose a random number for us.
2.
X equals to 2, which is between 0 and 4. Okay, Evan, could you have chosen x equals to 1?
Yeah.
And no problem. Could you have chosen something ugly like, I don't know, 2.5?
Yes.
Okay, Evan, you test x equals to 2. Kirana tests x equals to 2.5. Anu tests x equals to 1. What are you testing? You are testing the gradient. Now, tell me, people, how are you supposed to find the gradient at that point? Evan? How?
You take
Go ahead.
take coordinates.
X equals to 2, and then what do you do in order to find the gradient?
You have to find another pair.
Nothing that complicated. Look, Eben and everybody else, we're doing the left question, yeah? But your inspiration comes from the right question. Look at the right question. Look at the right question, Eben. He wants you to find the gradient, correct? See? He wants you to find the gradient. And then he gives you the location, x equals to 1, correct? What do you do? Well, because it's gradient, we always use dy dx. And then what do you do with x equals to 1? Just put it in You'll find the gradient.
So you want me
And
to derive it? Yeah.
do you already have the dy dx at the left question?
Left question.
Don't you already have the dy dx? Yes, we do. My goodness, that's the first
Yeah.
thing.
Oh, yeah. Oh,
That's
yeah.
the first thing that we do. Remember, I'm teaching you. That's the first thing that you do. I have dy dx. Confirm will be useful. So how do you find the gradient at a certain point? Just use your dy dx lah. Understand?
Okay.
Eben, Anu, and Kirana, you have your position to test. Please test by using your dy dx and then tell me the result. Everybody, go ahead. Of course, you can use calculator lah. At this point, calculator is very useful.
I think the gradient for 1 is 9.
Okay, which is positive 9.
Yeah, positive 9.
I'm going to ignore the number 9 and I'm just going to say it's positive. Do you know why, Anu?
Because
At this point, we are worrying about increasing or decreasing.
decreasing.
Positive means increasing, correct?
Yeah.
Negative means decreasing. We are just worrying about whether it's increasing or decreasing. It doesn't matter what the actual gradient is, if that makes some sense,
Oh, okay.
right? So, good job. Still very good job.
Wait,
Eben,
then why is it positive? Because before 0 and 0 is negative 1.
first thing first, look at the graph. Between 0 and 4, it is definitely positive, right? Look at that. Positive, right? There. Correct, correct.
Yeah, but wasn't I supposed to find the one like, oh, okay, never mind.
Got it? Got it? Okay, good. Good. Evan, what's your test result?
12.
Yeah, which is positive 12, correct?
Mm-hmm.
We only care about that, right? We only care that the fact that the gradient is positive. Kirana?
11.25.
And of course, it's an ugly number, but who cares? The gradient is positive. Hey, people, just by this simple test, it seems like a very random test, but you have confirmed the answer. The answer is from 0 to 4, the gradient is positive, therefore the y is increasing. Do you understand what I'm trying to say? One more time, find the range of value. Oh, from x0. Sorry, it's better written that way. From 0 to 4. The gradient is positive. Therefore, the y or the curve is increasing. That is the answer. Do you understand what I'm saying, people? Kirana? Good. 0 not included, please. 4 not included, please, because they are local maxima and minima. They are not increasing and not decreasing. Now, isn't it so easy for them to change the question? Oh, find the range of value of x for which y is decreasing. Eben, please answer for us. What is the range of value for which y is decreasing?
Wait a sec. X equal,
If your
Oh,
test
wait.
shown,
Wow.
if your test show that from 0 to 4, the gradient is positive, right? That's what your test and your Anu's and Kirana's tests are showing. Okay. Then the
Okay.
decreasing part, isn't it obvious also? If it's not obvious, please tell me.
Yeah, it's just after that.
After that, which means x bigger than 4, correct?
Yeah.
That means you're talking about this part, correct? Okay. Now, Eben, I would like to invite you to test that part. Test this part, please. Eben will test this part using any random value. Kirana also. And Anu, you will test this part. Would that be okay, Anu? Anu, Eben, and Kirana, do test those things. If you don't understand what I'm saying, please tell me.
So I test the part before
Zero.
zero.
Before zero, which using what number? Whatever number is convenient to you.
Okay.
Then I test 4 and above.
Forever. But you don't test 4. Why? You already know the answer is 0, man. Right?
Oh, yeah.
Right. Kirana, I hope you can follow.
Yep, I tested and I got a negative number.
Okay, what number do you test with?
I tested for -1.
-1, very convenient. Your gradient is whatever negative number, right?
Yeah.
Which should make a lot of sense to you.
Yeah.
Eben and Kirana, can I have a confirmation?
-15.
You test -50, am I correct?
Oh, no, sorry.
The x is?
Oh, yeah, the x is tested 5.
And then the gradient conclusion is -50.
15, sorry.
15, which is
Yeah.
negative, right? Which is negative. Nice.
Yes,
Kirana, which x do you test with?
Where I need to test again because I use 5 also.
No problem, no problem. You also get a -15, right? Now, obviously, Kirana and Eben, you're using the most convenient number, 5 lah. I mean, bigger number, less convenient, ma. I totally agree. I know you're using a very convenient number, -1. Totally expect that. But if you use 1,000 and -1,000, it's also totally correct. No harm there. Okay, people, do you understand increasing, decreasing, stationary point, blah, blah, blah? So far, clear or not?
Yeah.
Okay. This is the first time you see dy dx truly in action, gradient. Last week's question was more like a pure dy dx. You're just following what I'm doing. And that's fine, that's fine. But this kind of question is more prevalent, more application. In some sense, I hope it makes more sense. Do not be disturbed by the fact that you're using Desmos. Desmos is very important for learning at the start. Don't worry, after you use Desmos, after a while, you will no longer need Desmos. It's not that you are dependent on Desmos. Actually, after you use Desmos for a while, you will gain the understanding you do not need Desmos anymore. Don't worry about it. Yeah? Now, please understand, they can just ask increasing or decreasing. The answer is about the same, right? The answer is about the same. Now, let's look at the right question. In the end, we are talking about trends, In the end, we are talking about, hey, can I see the typical question they ask and can I use just the same method? Okay. Anu, do us the honor. If they ask for increasing or decreasing, what is the first thing we must think about?
Like, is it before the stationary point or like in between or after?
Which is to say, you have to find the stationary point first.
Yeah.
Right? This question, the right question, have we found the stationary point? Have we?
No.
No, correct. Just be clear, people, Anu, we have not. The only thing we have found for 2 mark is the gradient at a certain position. Correct? Easy lah. Even that is a little bit annoying because of the K. Hey, part B before part C asks you about stationary point, even though the wording is very weird. Correct, yeah? Now, I will change this wording so that it doesn't confuse us. Just treat this as find the stationary point also. Why? Because we need it for decreasing, increasing. In the end, that is what we need. One more time, for increasing, decreasing, we need stationary points. That is what I'm trying to impress upon you. Now, how do we find the stationary point? What do we use, Anu?
We need to like sub the gradient equal to 0.
Correct. And the gradient is dy dx equals to 3x squared plus 2kx minus 3 and then equal to 0, correct? Because of the stationary point. Now, I do note because of the k, it is impossible to find the x, correct? The k is the problem. Yeah? K is the problem. We cannot find it. Make sense or not, Anu?
Yeah.
Therefore, notice what the question do in part C. Do you know what the question do? The question takes out the problem, correct? The question gives us K and therefore makes our life easier. Now, at this point, Anu and everybody else, you're supposed to be able to do this question. Please do something about this and I'll follow you shortly. I'll give you 1 minute. Okay, so again, what do we do after this? Okay, people. Evan, tell me, what do we do after this step?
Find x again.
Okay, which is what do we do? You must have factorized, right? So tell us the factorization.
Oh, I didn't do it like that. Oh,
You use the calculator? That's totally fine.
yeah, I just use
Alright, the calculator is
calculator.
fine. So tell me the answer of the calculator. Should be
X
1/3 and 1, I think. X equals
3. First answer is 3. Second answer is -1/3.
3. Oh, yeah, correct. Or x equals to -1. Oh, you're right. Okay, then from that, we can acknowledge that this is -3 and this is +1, correct? You still have to write this middle one. This one is, you can do it after calculator. Eben, I agree with you using calculator. Okay, if you don't do this part, you lose 1 mark, but better lose 1 mark than than lose everything, correct or not?
Oh, okay.
I always suggest to all my students, yes, in amath, use your calculator, but if possible, gain the full mark by, leaving this empty first, leaving it empty first, and then you just complete the step afterwards. Make sense?
Okay.
Okay, so now we have this and we have this, and these two are your stationary points. Now, you do not know who is maximum and you don't know who is minimum, correct? Correct or not? You only know because of the decimals. So we pretend that we don't know. Then therefore, we do not know when is it decreasing and when is it increasing. Make sense? We do not know at this point. We're just pretending. So what do we do, Evan? Tell me. We do the test method. We do the test method, correct?
Oh,
We
okay.
test. What do we do with it? I guarantee you, test is a very formal method. It's so easy to do and it's very formal. So you test. So what do you test?
We test
Whatever is in the middle of these 2 points, correct? So
Yeah.
Evan, I will invite you to test this one. Kirana test this one, and Anu test this one. Okay, give me the result. Test, please. We will state the number you choose. Okay, any random is fine. Anything random.
Wait, sure. Do we not have to find the y to find the stationary point?
The question is, does the question ask you for the stationary point?
No, but then how do we because in the previous question we knew the
Okay, when you say stationary point, you mean the full point, meaning 0, 0 and 4, 32, right? You know the y also lah. At this point, you only know half of it. You only know the x part of the stationary point, correct?
Yeah.
Isn't that enough? Isn't that enough? To test, you only need the x ma, because dy dx only demand x ma, correct or not? Isn't it enough? Am I making any sense or not?
Mm.
You don't need the y for the test.
Oh.
Yeah, the y is if they ask, you give lah, you give. That's fair. It is true that you don't know fully, you only know half, but you don't need it.
Okay.
Okay, good question. Eben, Kirana, if you have some test result, please tell me already.
Yeah, I tested with -1.
Okay, -1, which is great. And then your answer is
8, +8.
+8, which is we focus on the positive part. Kirana, the most one.
I use 2.
2. I will say to you, Kirana, and everybody else, use 0, even more convenient. Correct or not? But using 2 is totally fine. Tell me what's the answer.
-7.
And we focus on the negative part, correct?
Yeah.
At this point, Eben and Kirana, you already know your part is increasing, no? Correct or not? You already know lah. Kirana, your part is decreasing. You already know. Correct or not?
Yeah.
Just like what the Desmos say. See, the test do replace Desmos. That's why they teach you the test method. It does replace Desmos. Okay? Anu, final test.
I put 4.
Yeah, that's great. And then the answer, the result is
13.
13, focusing on the positive side of things, positive, and therefore this is increasing. So now, Anu, close it for us. If k is equal to -4, find the range of values of x. For this, the y is a decreasing function. The answer will be?
-1/3
Mhm.
to 3.
Correct, but not including, yeah, not including. Kirana, do us a honor of answering if the question is increasing function, where is the range?
Wait. Is it? Can I put -1?
-1 is the correct answer, but he asked for the range, meaning he asked for everything, not just -1.
Yeah, -1 then.
No. Your answer must be like this. X smaller than -1/3. Does that make any sense? You cannot answer x equals to -1. That's only one answer. He asks you for the full answer. Make sense?
Yeah.
For
Then
example, you
it is
cannot, and then plus and what? This is only half the answer.
x is more than 3.
Very good. That's it. Look, that's the answer. Now, with that in mind, this answer, this part of the answer should be x bigger than 4 and also x smaller than 0. I hope all this makes some sense. That's the complete answer. Eben, do us a favor. The increasing, decreasing part, is it possible that they don't ask for a range, they just ask for a value? Or will they always ask for a range?
Maybe they'll ask for an exact value.
Maybe, but as far as you can tell right now, it's more like a range because that makes a lot of sense graph-wise. Correct or not?
Yeah.
In general, a graph is increasing through a certain part. So like it or not, the question must be a range. It's not that they're trying to confuse you. It's just that it's the nature of the graph. I hope that makes some sense, Evan.
Okay.
Okay. Now, there's only one thing I haven't covered. This one, the whatever this second derivative test to determine the nature, blah, 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 blah. There is a reason why I don't explain that. First, let's recall what we have done. We have compared two questions. We have used a lot of dy dx with some other things. But most importantly, you have understood how a graph works. This is the meaning of today's lesson. Dy dx is a very big part of it because it's gradient of a graph. A graph always have a gradient, man. A curve always have a gradient, and now you're learning how to use dy dx. Why is a gradient? Turns out it's quite a powerful thing. Turns out this is still basic knowledge, is so much used, you have to understand it fully. Not just because of the marks. The marks is big lah. Let's be fair. The marks are big. So, yeah. Before I explain whatever second derivative test, blah, 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 let me confirm, is there any other question?
Yeah, like
Mhm.
you say that the dy dx is the
Gradient.
gradient.
Yes. Always and always and always.
So the gradient is like always the same.
No. Your concept of gradient as a number must change.
Okay.
Why? A gradient is, of course, a number. I understand. But a curve have a changing gradient, correct?
Yeah.
Therefore, look at dy dx. Now it makes a lot of sense, Evan, that a dy dx is not a number. Look at that. Not a number originally, correct?
Yeah.
It is whatever x lah. Why? Because it adapts. It adapts. He knows that a curve have a changing gradient, so he gives you something which is not a number. And then if you give him x equals to 1, then it will turn into a number. You
Okay.
must give the dy dx a certain position. He will tell you the exact number. If
Oh,
he give him a different position, x equals to 2, what kind of number will he give you? A different number. Understand or not?
okay.
Because
Yeah.
that is correct one. That is what you expect. The dy dx must not be a number, but a changing number. It
Oh.
depends on the position. Does this make a lot of sense, Evan?
Okay. Yeah.
So therefore, do not expect dy dx to be a number unless you specify the position. If you specify the position, he should give you an exact number. Clear?
Yeah.
A very good
Okay.
question. Any other question before we continue? Okay, good. Now, this second derivative test, second derivative, you just differentiate one more time. Frankly speaking, it's very easy to do. Differentiating this is extremely easy to do. I will not do that. First of all, it's easy. Secondly, the test is not just to differentiate. You have to do something else with it. I will let your teacher teach it. Okay? I have two reasons for it. The first reason I'm not teaching here is because the second derivative test is more like a memorization test. People tend to forget what it means. Today, I'm concentrating solely on the understanding. You do notice that today we focus a lot of understanding. Okay? The second derivative test is not a lot of understanding. Okay? That's the first reason. The second reason is we are lucky this time the function very easy. Second derivative test becomes easy if the function is easy. If the function is complicated, the second derivative test is, for lack of a better word, a pain in the butt. Second derivative test is difficult to do if the function is difficult. That's not something nice. It's not something good to learn, something like that. Just because this question asks you for second derivative test doesn't mean that next question will ask you. The next question might simply say, determine the nature of the stationary point. They never specify second derivative test. And that is what I'm teaching you. I'm teaching you the more general, better method. Only when the question specify, you must use a second derivative. So let's forget second derivative. Am I making some sense? I need to see some thumbs up here. Okay.
Okay.
Now,
Yeah.
yes, Evan?
So we don't need to learn it, or
Your teacher will teach it.
okay.
Okay. Whenever I say your teacher will teach it, I consider it something not very difficult. It is detailed, but it is also not very important. That's the most important thing. So you do need it sometimes because they ask. Just learn it from your teacher. I guarantee you won't be confused. Fair?
Okay.
Things that are important, I emphasize a lot in holiday tuition. Now, please understand the question first. Determine the nature. You have Desmos ma, you know it's local maxima, local minima. Anu already pointed out, but if I don't have Desmos in exam, how? How do you determine the nature? Turns out, you already know how. So this is to answer Anu's question. I don't have the graph. How do I know it's local maxima or local minima? Extremely easy. The method you already have learned. This is the method. Let me repeat this one more time. The method to know this is local maxima or minima is the same exact method to find out whether it is a decreasing or increasing part. The exact same method. It's so good that way. Okay, now let me do another. Okay, let's ignore this for a while. Remember the test? Let's say you have two stationary points, but you do not know it's maxima or minima, right? You don't know. The gradient, which is the dy dx, you go and test it out, and you come up like this. Of course, this is 0 and 0. And then you have two possibilities. This is a positive, a negative, and a positive. That's one possibility. The second possibility is, usually there are only these two possibilities, okay? Usually. 0, 0, m dy dx, right? You test, you end up negative, positive, negative. Just by looking at this, you immediately know who is maxima and minima. I will make it extremely clear for you. Remember, we are not learning something new here. We're just reusing something we already know. Here's a positive gradient. Here's a negative gradient. Here is a positive gradient. Just like that, you know this is maxima or minima already. Anu, I'm going to invite you to make a guess. Is that maxima or minima?
Maximum.
Because the graph is so obvious, correct or not?
Yeah.
The other one, Eben, this guy. Look at the shape of the neighbor. You already know lah. This is maxima or minima.
Sorry, which guy?
Okay, one more time. You do not know whether this guy is maxima or minima, right?
Yeah,
You make a test of their neighbors, and the neighbor test comes out as positive, negative, positive, correct?
Oh,
I claim you immediately know who is this guy. What is this guy? Local maxima or local minima?
positive, negative. Am I looking at the right slide?
I am. Are you looking at the star here? Correct. You're looking at this one, right? You're looking at my screen sharing. Am I correct?
Yeah.
Okay. You're looking at this part, correct? You're looking at this part. Are you looking at?
Which? Oh,
Wait. Do you see a star? Wait, Evan. Do you have problem screen sharing? What's going on here? Do you see a star? Did I draw a star just now? Evan, you're muted.
yeah, my display. Not sure the displays. Okay.
Do you now see two tables with one star?
Yeah, I only saw the bottom one. I see now here.
Okay. All right. Okay, Evan. So we were discussing that. And then I was asking you, this guy, I am so sorry. This guy is local minima or local maxima? Based on the neighboring shape. The neighboring shape looks like this.
The minima.
Correct. It's so obvious from the neighbors. Do you understand? It's so
Yeah.
obvious from the neighbors. And that is how we determine the nature of these points. It's so visual. That's why I like it. Most people like visual stuff. Kirana, The other option is negative, positive, negative after the test, okay? Draw, draw, draw. This guy, local maxima or local minima?
Minimum
Obvious, right? This guy, local.
and maximum.
Do you need any other explanation besides the fact that it's visually obvious?
No.
And that is what I'm trying to teach you today. Don't underestimate this table. This test table will give you a lot of marks and give you a lot of confidence. That's the most important thing. It can determine the nature. It can answer increasing, decreasing. It has one more use. Maybe next week I will reveal. Guys, do you understand? Okay. You have answered, determine the nature of this point. Okay. You have answered. I'll give you 2 minutes to finish up your own notes, and then we'll look at the trend. We'll finish up with the 10 minutes, look at trends, okay? Give you 2 minutes. If you have question at this point, you should ask them. Needless to say, this is very precious skills, giving you a lot of confidence, right? That's the goal, huh? Okay. People, I'm leaving as a blank right now. Yeah, Anu, I invite you to not look at the questions just now. I invite you to look at a blank part. Eben and Kirana, look at those 2 questions we have just described. We have just done, okay? Anu, don't look at them. Eben and Kirana, look at them. We're going to describe the trend. Trend means how they ask questions. Needless to say, it's very beneficial if you know how they ask questions. Okay? Anu, do they give you anything? Do they give you a lot of things at the start if you try to remember the question?
No.
What do they give you if you remember?
The equation of the curve.
That's it. People, Eben and Kirana, I hope you can see it by yourself. They just give you y something something. Give the curve, right? Give the curve. Whether the curve is intimidating or not, it depends on them. But that's what they do. Anu, they can give you, however, a slightly annoying thing. What is it? Within the curve, Within the curve, they give you something slightly annoying. What is it?
Okay, unknown.
Yeah, they may put an unknown. That disturbs some people, and we have to learn how to deal with it. In fact, the most they can do is to put 2 unknowns. Okay. 1 or 2 unknowns, but 2 is the most. More than that is senseless already. This is still considered a trend. They do that quite easily. Anu, if you remember, is there anything else that they give you?
They might give us the like x is equal to 1 or something.
That's fair. We'll move on later. Notice one thing, Anu and everybody else, they will never give you the picture. Or do they lah? Do they usually give you the picture? We'll say usually no. That's the trend. Make sense?
Yeah.
Okay, because the picture makes things too easy lah. Correct or not? Correct, yeah? Okay. Now, the trend will be what they ask lah. So Anu, can you tell us from your memory, Eben and Kirana confirm, what do they ask?
They ask us to find the stationary point.
They call it stationary point, correct? Stationary point, which may be more than one. And then regarding the local maxima minima, that is the second question, right?
Yeah.
Determine the nature, correct?
Yeah.
Okay, determine the nature. What else do they find? Otherwise, they ask you.
Then the range in which y is positive or negative.
Not y, that's the y dx. Now you call it range of y increasing or decreasing. Correct? That is what they will ask. Correct?
Yeah.
I will sharpen a little bit. Finding stationary points means they tell you it is given. Sorry, I'll just say it is given. M equals to 0, correct? Find x, comma, y. Make sense?
Yeah.
Does this make sense? Now, Anu, I will put something at the start. They may actually ask you, like, given x, meaning the position, correct? Find gradient, correct? They also can do that. Anu and everybody else, please notice this. It's very simple. If they ask you to find stationary point, they are telling you m equals to 0. You have to remember that yourself. If they give you the position x, they should ask you to find the m. If they give you the m, they should ask you to find the x. It's really that simple. That's just a very simple variation they will do. It's too simple if you think about it. Okay? All you did. Yes, Anu?
So if they give us the x and ask us to find the m, so we should put it inside the like
The dx lah.
yeah, okay.
Right? And they ask you for stationary point, giving you the m, you still find the dx first. Correct or not? You still do it.
Okay.
So for everything, for all this variation of question, people, you need dy dx, correct? You need dy dx. And then you need the test table, and then that's it. Look. Desmos is, just nice for fun. This is maybe 10 marks already, usually slightly more. Eben and Kirana, you're the one that look at the question. Does this summary of trend make any sense?
Yeah.
Kirana? Now, expect this to happen. This is one of the easiest question. Easiest doesn't mean you'll get full marks. I expect you in pressure test, starting Sec 4, okay? Starting Sec 4. I expect you in pressure test, you get full marks every time. First of all, they'll make you happy. Secondly, it's done very easily most of the time, giving you more time, blah, blah, blah. Okay? Thirdly, this is basic skill for everything else, for every other differentiation question. Now, we ran out of time. I was hoping to cover another question, so never mind. At this point, if you have any other question, please ask them. If not, let's call it a day. Okay. Anu, I will see you on, if you can come on tomorrow, that's great. Okay, if not, I'll see you next week.
Bye-bye. Thank you.
Okay. Eben and Kirana, any questions?
No
Don't
questions.
Remember the trend, remember the skill. Kirana, I'll send you the video also. We'll use this again next week or tomorrow.